everyone, welcome back to our chemistry channel. Today we are diving into the fascinating world of alkenes. So what are alkenes and why are they so important? Alkenes are a type of hydrocarbons, which means they are made up of hydrogen and carbon atoms only. But what sets these alkenes apart from other hydrocarbons like alkanes? The key difference lies in the bonds between the carbon atoms. Alkanes have only single bonds, but alkenes have at least one double bond between the carbon atoms. And this double bond is what gives alkenes their unique properties. This double bond allows very many reactions to take place. So this is, as a result, makes alkenes more prone to reactions. So these double bonds break and react with other compounds to make alkanes, and thus you see that they are more reactive than alkanes. So therefore they are called unsaturated hydrocarbons. Hope that's clear enough. So therefore even their general formula is different, CnH2n. So if you see, the number of hydrogens that are there are twice of that of the carbon atoms that are in alkanes. So the other possible alkenes in the homologous series, it begins with ethene, then propene, butene, pentene. Now, if you notice, there is no methane. Now, why is there no methane here? Because to form an alkene, you need at least two carbon atoms. To form this double bond, at least two carbon atoms are required. So in meth, that is methane, if it has to be, there is only one carbon atom, and thus methane does not exist. It not only forms straight chain compounds, but it can also form branched compounds. Like here, if you see carbon, carbon. So in this case, when it forms a branch in this alkene, if you see, we have the main carbon chain made up of four carbon atoms. So here you go, 1, 2, 3, and 4. So four carbon atoms, including the double bond. So here you see the double bond is here. So the branch gives the prefix. Now here, the carbon that is here, it is a branch that gives the prefix. You remember in my videos, one of the parts of organic compounds, we learned that wherever there is a loss of one hydrogen, it comes in the alkyl group. So here it has one carbon and one hydrogen is lost. So this branch is called methyl. It's called methyl. And which carbon is it attached to? It is attached to carbon 2. So it's 2-methyl. And the suffix follows the name of the main carbon chain. So this is our main carbon chain. And how many carbons are there? There are 4 carbon atoms. So if there are 4 carbon atoms, it's going to be but. So double bond, butene. So the name of this molecule is 2-methyl butene. So how are you going to number this? Like here you have the numbers 1, 2, 3, and 4. You have the numbers. So how are you going to number? Start numbering from the end of the chain closest to the double bond. The goal is to give the double bond the lowest possible number. So if I number it this way, so 1, 2, 3, and 4. So which is the lowest number here? 2. So I will take the number. I will start numbering in this manner because my goal is to give the double bond the lowest possible number. Note any branches or groups attached to the main chain. Give them numbers based on their position. So here, if you see, the methyl group is attached to the second carbon. The double bond is also on the second carbon. So the name comes in as 2-methyl butane. Hope that's clear. Now let's look at the reactions of alkenes as a result of its double bond. So the reactions of alkenes include addition reaction, hydration, combustion, and polymerization. So in this video, we are going to deal with the first three reactions. Polymerization we will do when we are doing polymers. So first, let's look at addition of hydrogen. Now here, this reaction is also called hydrogenation. It's called hydrogenation. Now look at the name. The name hydrogen is here. So from this, you can get a clue that this process, this reaction is also called hydrogenation. So what happens here? So in this case, the carbon double bond carbon breaks. Okay, the double bond breaks, and also the bond between the hydrogen molecule. So hydrogen atoms break open. So each hydrogen atom joins with each of the carbon that is here. As a result, it forms one molecule. It forms one molecule, and that's an alkane. So in this case, ethene reacted with hydrogen to form an ethane. So remember, when alkene breaks the carbon double bonds and joins with the two hydrogen atoms, it's called, it forms an alkane, and this process is called hydrogenation. So here you see an unsaturated, it becomes a saturated alkane. So unsaturated is prepared for reaction. And remember, saturated molecule hydrocarbons are not prepared for any, they cannot react, they are unreactive. Therefore, this process is also called saturation. This reaction can also be called saturation reaction. So our next reaction is addition of halogens, and similar to hydrogenation, the carbon double bonds break, and the bonds on halogen also breaks. So now basically for your level, the IGCSE level, you need to know about bromine, addition of bromine and chlorine. Okay, so these are the two reactions that you need to know. So when a halogen is added, it breaks the double bond, and each carbon atom forms a new bond with the halogen atom. And what happens is this: the alkene, it reacts with you know that halogens are diatomic molecules, so always, whether it is Br2 or Cl2, so they are diatomic. So what is formed in the process? A dihaloalkane. A dihaloalkane is formed. So in this case, if you see here, it is 1,2-dibromoethane, because there are two bromine atoms in the molecule, and ethane represents the main carbon chain. So here you go. So two carbon atoms are there. So it is eth. So ethene. Now the bonds are broken from the double bond has become single bond, so it becomes ethane. So the main chain is ethane, and there are two bromine atoms attached in the molecule, and ethane is the main carbon chain. So this is called 1,2-di. So di is 2-dibromoethane. This is a very important reaction, because our reactants here are alkenes. They are alkenes, and they are halogens. So here, what happens here is when you add a colorless substance. So when you add something which is colorless to something which has color, brown, bromine is brown bromine. So liquid brown bromine. So it looks like an alliteration, right? So when this is added, the solution form becomes colorless. So this is basically decolorized. So this is a very important visual test. It's a very important visual test for the presence of alkenes. So, so let me repeat. When bromine is added to ethene, the double bond breaks and each carbon atom bonds to a bromine atom. And what is the result? The product is 1,2-dibromoethane. Okay. And, like this is just the double bond is, attacked. It attacks the bromine molecule, forming this compound. Okay. And of course, it's a very important test, visual test to check the presence of alkenes. So the reaction with bromine can be used as a test for alkenes. So what happens? The reddish brown color of bromine disappears when it reacts with an alkene, indicating the presence of a double bond. So here you see, so alkenes have a double bond while alkanes have only a single bond. So if you add bromine water to it, with alkenes, the color will change from reddish brown, orange to colorless. But with alkenes, there is no change. So this is an important test which will be asked in the exam. So this is how you distinguish between alkenes and alkanes. So our next reaction is hydration. Similarly, here, the double bond in the alkene reacts with water. It reacts with water, resulting in the addition of the hydroxyl. Now, you know water is H2O. You have this, okay? Sorry. So it forms the hydroxyl, ions, hydroxide ions, OH ions. Okay, let me write that here. So it forms the OH and H plus ions. So here, the double bond in the alkene, it reacts. The double bond reacts with water, resulting in the addition of this hydroxyl group to one carbon atom and the hydrogen atom to another carbon atom. So that's how an alkene, it reacts with water to form an alcohol. To form an alcohol. The conditions of hydration of alkenes is that there should be an acid catalyst, sulfuric acid or phosphoric acid. The temperature should be around 300 degrees centigrades and the pressure should be 60 to 70 atmosphere. So these conditions help facilitate the addition of water to alkenes, forming alcohols efficiently. So here you can say steam instead of water, you can say steam. In common with all hydrocarbons, alkenes burn in air or oxygen to give carbon dioxide and water. For example, this is the reaction. So watch this reaction. So it gives carbon dioxide and water, but this isn't a reaction anybody would ever choose to do because alkenes are much too useful to waste them by just burning them. But you should know that when there is a lack of oxygen, the alkenes give carbon monoxide, which is poisonous. Let's skip the polymerization reaction. We will learn in detail about it when we do polymers. Now, coming to a small mind map on alkenes. So, all the reactions are kind of summarized here. So, when alkenes react with alkanes, they form haloalkanes. So, remember the hydrogen bonds, the bromine bonds break, the carbon bonds break open, and the carbon atoms join with the bromine to form dibromopropane. So haloalkanes are formed. So haloalkanes are formed. And here in this case, when propene reacts with hydrogen chloride, again, the bonds break, the carbon bonds, double bonds break, hydrogen and chloride bonds break, and hydrogen and chloride combine, they join with each of the carbon atoms that are there to form 2-chloropropane. And how is that 2 coming there? It comes because of the number. So wherever it is attached, so you number the carbons. We saw the numbering also. So the next reaction is the hydrogenation reaction, similar to the addition of halogens. The bonds break open, hydrogen bonds also break open, the atoms combine with each other, and the process is called hydrogenation, where an alkane is produced. So propene becomes a propane. So the next reaction is the hydration reaction, where the conditions are important. You need a catalyst. Here in this case, it's a phosphoric acid catalyst. Temperature is 300 degrees centigrade. So this is steam that reacts with an alkene, and so you need 60 to 70 atmospheric pressure. So remember, this is a small mind map which will help you remember the reaction of alkenes. Let's apply what we learned just now using a few past paper questions. So the question here is, ethene can be produced from ethanol. Draw the structure of ethene to show all of the atoms and all of the bonds. So first of all, eth. So eth means there should be 2 carbons. And it's an ene, alkene. So there is a double bond. Now fill up the spaces. So every carbon should have four place spaces that needs to be filled in. So 1, 2 bonds are already done. So you have another here, and it's an hydrocarbon. Remember, alkenes are hydrocarbons. So you can have only carbons and hydrogens. So this is an ethene molecule. Question carefully, pause the video and try to answer. The structures of 7 compounds or elements A, B, C, D, E, F, and G are shown, and state the structure that represents a saturated hydrocarbon. So remember, for saturated hydrocarbon, what are the conditions? So it should have single bonds only, and it should be a compound. It's a hydrocarbon, so it can have only carbons and hydrogens. So A has carbons and hydrogens, and it has single bonds. So it kind of satisfies the criteria. So A could be the answer, but don't, leave the other options. Try to see them as well. So double bond, it has double bond. So this is not a saturated hydrocarbon. It's an unsaturated hydrocarbon. So C is also an unsaturated hydrocarbon. Here, this is not even a hydrocarbon because it has a phosphate in it. And then you have oxygen here. So this is also not a hydrocarbon. Sulfur, not a hydrocarbon. And this is the structure of diamond. The carbon atoms are tetrahedrally arranged here. So the answer is A. Now go name the 2 products formed when the hydrocarbon fuel undergoes complete combustion. So what are the 2 products that are formed? So it's carbon dioxide and water. Carbon dioxide and water. Okay, let's move on to the next question. So the 4th question is, ethane is an alkane which undergoes a photochemical reaction with chlorine as shown. State why this reaction is described as photochemical reaction. So why is this described as photochemical reaction? Because it requires UV radiations or UV light. So it's ultraviolet light. Okay, let's move on to the next question. So the structures of 4 organic compounds, B, C, D, and E are shown. So watch carefully. State which compound. Now this is a question for carboxylic acid. So we'll skip this question and go to the next. State which compound B, C, D, or E is a saturated hydrocarbon. So as I told you earlier, for a saturated hydrocarbon, what are you going to look for? Whether they all have single bonds and whether it's a hydrocarbon. So carbon and hydrogen. So C seems to be, C seems to fit into this, criteria. So C will be the answer here. So let's go to the next question. State which compound B, C, D, or E is an unreactive compound except in terms of burning. So what is unreactive? Saturated hydrocarbons are unreactive. So this is a saturated hydrocarbon. So C is the answer again. So state which compound B, C, D, or E decolorizes aqueous bromine. So which decolorizes aqueous bromine? It's an alkene. So alkene, how are you going to find out? By the double bond that it has. So D is the answer. So now let's move on to the next. So members of one homologous series only react with chlorine in the presence of sunlight. So name a member of this homologous series. So the homologous series is alkanes, and you can name any member. I choose to, use methane. Okay, so name two products that form when the compound in A reacts with chlorine. So what are they? Now tell me. So if methane, if it is going to react with chlorine, remember it needs UV light. That's the condition. So what will you get? What are the products? The products will be chloromethane. It will be chloromethane and hydrochloric acid. So the answer would be chloromethane and HCl. Is that clear? So describe how aqueous bromine can be used to distinguish between a saturated hydrocarbon and an unsaturated hydrocarbon. So what are the observations with saturated hydrocarbon? So with saturated hydrocarbon, there will be no change. No change. And the bromine, see, remember I told you brown bromine. So the solution will remain brown. But with unsaturated hydrocarbons, the bromine will get decolorized. Decolorized. Remember, alkenes react with bromine in the addition reaction, where the bromine adds across the carbon-carbon double bond. This reaction will decolorize the bromine solution, turning it from reddish brown to colorless. Or you can also say bromine gets decolorized. I'm sure the next one is going to be super easy for you all. So try it on. So structures of 7 compounds or elements A, B, C, D, E, F, and G are shown. So state which structure represents an unsaturated hydrocarbon. So remember, unsaturated hydrocarbon should have a double bond and it should be a hydrocarbon. So it should have hydrogens and carbons only. So try to locate it. So from what I can see, G fits correctly into that criteria. So G will be the answer. So let's move on to the next. So ethene can be produced by cracking long chain hydrocarbons to form short chain hydrocarbons. So explain why long chain hydrocarbons are cracked to form short chain hydrocarbons. So we saw that the short chain hydrocarbons like gasoline and diesel, they are more desirable as fuels for vehicles and machinery due to their higher volatility and better combustion properties. So gasoline is a small chain hydrocarbon which is used in cars and it ignites easily. So the answer could be the higher demand for short chain hydrocarbons. So what are the conditions for cracking? So the conditions are for catalytic cracking, you require very high temperature, say from 450 degrees to 550 degrees centigrades, and the atmospheric pressure should be a little above the normal, and there should be a solid acid catalyst. Example, zeolites. So write your answer down. So you need catalysts like zeolites, and you need a very high temperature. So cracking is an example of thermal decomposition. State the meaning of the term thermal decomposition. So remember, therm means heat and decomposition means breakdown. So it's breaking something using heat. Or in simpler terms, we can just say that breaking a compound breaks, okay, breaking a compound into simpler substances when it is heated. Thanks for watching. If you've enjoyed this video, don't forget to like, comment, and subscribe. See you in the next one.